derivative of f of x, function f of x, using maxima. So all of we know that if f of x is the given function, then its derivative is denoted by the function denoted by f dash x, and it is equal to limit h tends to 0 f of x plus h minus f of x divided by h. If this limit exists, then it is called the derivative of f of x. Okay, for example, if f of x is equal to, say, f of x is equal to x square, then f dash x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. So it is equal to, now what is f of x? F of x is x square. So what is f of x plus h? F of x plus h. So in place of x, we want to replace x plus h. So it is x plus h bracket square, and therefore f dash x is equal to limit h tends to 0 x plus h bracket square minus x square divided by h. So if we simplify this bracket, then it is equal to limit h tends to 0 x plus h bracket square is x square plus twice xh plus h square minus x square divided by h. So here x square will get cancelled here, and it is equal to limit h tends to 0 twice xh plus h square divided by h. Now from numerator, if we take h outside, then it is equal to limit h tends to 0, if we take h outside, inside the bracket twice x plus h divided by h. So this h will get cancelled here, and we get finally limit h tends to 0 twice x plus h. Now if we take the limit as h tends to 0, then we get it is equal to twice x plus 0. So it is equal to what? Twice x. So the derivative, if f of x is equal to x square, then f dash x is equal to twice x. So now in Maxima, we are going to see how to enter a function and how to find the derivative of the given function. So first we are going to create a list of formulas here. If f of x is equal to, say here f of x and it's f dash x. So first, if f of x is equal to constant, say if it is equal to, say, 1, f of x is equal to 1, then its derivative is equal to what? 0. So in Maxima, so if you enter here, say f of x is equal to, so to enter a function, say f of x is equal to double dot equal to 1, okay, is equal to 1, and then want to determine derivative of f of x with and variable, independent variable is what? X. So now you can see here derivative is what? 0. So if it is a constant function, that is if it is equal to k and k is a constant, then its derivative is equal to what? 0. So if it is equal to 2, 3, 4, 5, 6, 7, then the derivative of constant function is equal to what? 0. Next, if f of x is equal to x, then f dash x is equal to 1. What is f dash x? It is equal to 1. Or I am writing here, instead of this, we are going to create a table. Yeah. Say here f of x, I am writing f of x and f dash x. So if it is equal to, say it is equal to 1, then its derivative is equal to 0. If it is equal to, say, k, then constant, if it is a constant, then derivative is equal to 0. If it is equal to x, then derivative is equal to what? 1. So again in maxima you can check here if f of x is equal to, say f of x is equal to x is equal to x, and if we write here differentiation of f of x in the variable x, you can check it is equal to what, derivative is equal to what, 1. So if f of x is equal to x, then its derivative is equal to what, 1. Next if f of x is equal to 1, say f of x and f dash x, so if it is equal to x, derivative is 1. If it is equal to x square, then its derivative is equal to what, twice x. Similarly, if it is x cube, then derivative is equal to thrice x square. That is, if it is if it is x raised to n, then its derivative is equal to n x raised to n minus 1. You can check here in maxima also, if f of x is equal to, say here f of x is equal to, if we write here f of x is equal to say x square, then you can check here f of x is equal to x square, and if we write here its derivative differentiation is what, twice x. So if it is equal to x square, then its derivative is equal to what, twice x. So if it is equal to x cube, if it is equal to x cube, instead of 2, if you write here x cube, then f of its derivative is equal to, it is equal to thrice x square. So now next similarly, if now, so this is the one formula, if it is equal to x raised to n, then its derivative is equal to what, n x raised to n minus 1. Next, if it is equal to, if f of x is equal to 1 by x, then f dash x is equal to minus 1 upon x square. So in maxima also you can check here, if f of x is equal to, say here f of x is equal to 1 by x, then its differentiation is equal to minus 1 by x square. So minus 1 by x square. Next, if f of x is equal to 1 by x square, f of x is equal to 1 by x square, then we can write this is equal to x raised to minus 2, as we know that 1 by a is equal to a raised to minus 1, or 1 divided by a raised to n is equal to a raised to n minus 1. Then f dash x is equal to minus 2 x raised to minus 3. Okay, so this is equal to minus 2 divided by x raised to 3. So if f of x is equal to 1 by x square, then its derivative is equal to what, minus 2 divided by x cube. So here you can check also, if f of x is equal to say 1 by x square, so you want to write here 1 by x square, then its derivative is equal to minus 2 by x cube. You can check here, if f of x is equal to 1 by x square, then its derivative, this by using this command diff f of x, and independent variable is x, its derivative is equal to what, minus 2 by x cube. From this we can write, if f of x is equal to, say f of x is equal to 1 by x cube, means what, it is equal to x raised to minus 3. Then by using the formula, first formula, that is what, x derivative of x raised to n is n time x raised to n minus 1. By using this formula we can write this is equal to minus 3 x raised to minus 3 minus 1. So this is equal to minus 3 x raised to minus 4, which is equal to minus 3 divided by x raised to 4. So this is the derivative of f of f dash x. So what is f of x? If it is equal to x 1 by x cube, then it is minus 3 by x raised to 4. So here if you write it is equal to, say here x cube, instead of x square if you write x cube, then its derivative is equal to what? Its derivative is equal to minus 3 by x raised to 4. So from this we can write, if f of x is equal to 1 by x raised to n, then its derivative is equal to minus n divided by x raised to n plus 1. The next formula is f of x is equal to, if f of x is equal to e raised to x, then f dash x is equal to e raised to x. So here in maxima, if you write here f of x is equal to, say I am writing here one more, f of x is equal to x is equal to write an exponential function, we write it as a exp of x, and then to find a derivative, derivative of f of x, independent variable is x, then you can check its derivative is equal to what, e raised to x. So if f of x is equal to e raised to x, then its derivative is equal to what again, e raised to x. So if f of x is equal to e raised to x, it is f dash x is equal to e raised to x. Next, if f of x is equal to log x, then f dash x is equal to 1 by x. So here in Maxima also you can write, if f of x is equal to say, to enter log function, you just write down here, say f of x is equal to log x, then, and to find a derivative diff, just enter this command, f of x, independent variable is x, so it is equal to what, 1 by x. So if f of x is equal to log x, then its derivative is equal to what, 1 by x. The next function is trigonometric function, or if it is equal to say f of x is equal to 2 raised to x, then it is equal to f dash x is equal to 2 raised to x log 2. So if it is, you can write here, say here f of x is equal to, say f of x is equal to 2 raised to x, then derivative of f of x in the variable x is equal to, you can check here, log 2 into 2 raised to x. So if f of x is equal to 2 raised to x, then its derivative is equal to what, 2 raised to x log 2. So in general, if f of x is equal to a raised to x, a is any real number, then its derivative is equal to a raised to x log a. Next, we are going to determine derivative of trigonometric function. So the derivative of trigonometric function, if f of x is equal to sin x, then f dash x is equal to cos x, and if f of x is equal to cos x, then its f dash x is equal to what, minus sin x. If f of x is equal to tan x, then f dash x is equal to sec square x. If f of x is equal to cot x, then f dash x is equal to minus cosec square x. If f of x is equal to sec x, then f dash x is equal to sec x into tan x. Then if f of x is equal to cosec of x, then f dash x is equal to minus cosec of x into cot x. So now how to check, how to find a derivative of trigonometric function using Maxima. So to enter trigonometric function, just write down here, you can write f of x is equal to, say f of x is equal to sin x, or you can directly write here f of, you can directly use differentiation diff of sin x in the variable of x. So you can use this also, you get directly it is equal to what, cos x. Similarly, if you write here it is equal to cos x, or I am writing here, say diff, by using this command, say it is equal to cos x, in independent variable is x, then its derivative is equal to what, minus sin x. You can check here. So derivative of sin x is equal to cos x, and derivative of cos x is equal to what, minus sin x. Next, if it is equal to tan x, so now if f of x is equal to, directly you can write differentiation of tan x, independent variable is what, x, and you will get its differentiation is equal to what, sec square x. Next, if what is the next formula? So tan x, derivative of tan x is equal to sec square x. Now derivative of cot x is equal to, so differentiation of cot of x, independent variable is x, so it is equal to minus cosec square x. So minus cosec square x, you can check here. Now to enter sec x, so you can enter, so using the command diff, so sec x, sec of x, independent variable is x, you can check here its derivative is equal to what? Sec x into tan x. Similarly, if you write here f of x is equal to or you can write it directly diff, differentiation of say cosec x csc of x, and independent variable is x, you can check it is equal to minus cot x into cosec x. So to enter cosec x, just enter csc of x. So for the remaining trigonometric function, you just enter sin x, cos x, tan x, cot x, sec of x. But for cosec x, for only this function in Maxima, you can write it as a csc of x, and you will get the derivative is equal to what? Minus cosec x into cot x. So now next, you can also find derivative of a inverse trigonometric function, say, or hyperbolic function. So first we are going to find for inverse trigonometric function. As we know that the d by dx of say sin inverse x, if f of x is equal to sin inverse x, then its derivative is equal to, then f dash x is equal to 1 divided by under root of 1 minus x square. So how to enter inverse trigonometric function in Maxima? So for write f of x is equal to say a sine of x. So if you write this is a sine of x, then the derivative of f of x in terms of independent variable is x, you can check it is equal to 1 divided by under root of 1 minus x square, or you can directly write derivative of a sine of x, independent variable is x, so it is equal to 1 divided by under root of 1 minus x square. Similarly, for cos inverse x, you just write down it is equal to, if you write here a cos of x, say a cos cos of x, that is equal to minus 1 divided by under root of 1 minus x square. So if f of x is equal to cos inverse x, then f dash x is equal to minus 1 divided by under root of 1 minus x square. Now if f of x is equal to tan inverse x, then f dash x is equal to 1 divided by 1 plus x square. For cot inverse x, f of x is equal to cot inverse x, f dash x is equal to minus 1 divided by 1 plus x square. So here, if you write here derivative of a tan x with independent variable is x, then diff, and you can say it is equal to 1 divided by 1 plus x square. If you write it is a cot of x, cot inverse of x, so to enter inverse trigonometric function, just write down a, okay, in front of trigonometric function, that is a. If you want to find a sine inverse x, then write down it is a sine. For cot inverse x, write down a cot. Similarly, if you want to determine say a derivative of a sec of x, independent variable is x, then you can check it is equal to 1 divided by it is equal to square root of 1 minus x square, 1 divided by x square, outside bracket is what, x square. If you simplify this, if you simplify just into rat sim, since previous command for percent, we can check whether it is simplify or not. Yes, it is simplifying. To simplify this function, simplify this term, we just enter the command rat sim and we get sec inverse x is what, 1 divided by mod of x into square root of x square minus 1. So what is the derivative of sec inverse x? So f of x is equal to sec inverse x, then f dash x is equal to 1 divided by mod of x into square root of x square minus 1. Similarly, for a, if you write here, it is equal to derivative of a cx, that is cosec inverse x, independent variable is x, then you can check here, it is minus 1 divided by square root of 1 minus 1 by x square, and outside the square root it is x square. But if you want to simplify this function, then just enter here rat sim, and since it is a previous command, to simplify the previous command, just enter the percent sign, and you can check it is equal to minus 1 divided by mod of x into square root of x square minus 1. So here for f of x is equal to say cosec inverse x, then f dash x is equal to 1 divided by minus 1 divided by mod of x into square root of x square minus 1. Similarly, you can enter the hyperbolic function also. So for the hyperbolic function, as we know that if f of x is equal to sine hyperbolic of x, then f dash x is equal to cos hyperbolic of x, or if it is equal to, say, f of x is equal to cos hyperbolic of x, then f dash x is equal to sine hyperbolic of x. So here, to find a hyperbolic derivative of hyperbolic function, just enter here f of x is equal to, or direct you can write differentiation derivative of sine hyperbolic of x, independent variable is x, and you get the cos hyperbolic of x. Similarly, if you write here differentiation of cos hyperbolic of x in terms of x, then it is equal to what, sine hyperbolic of x. So if you combine all these formulae in one list, we can write, if it is equal to, here I am writing f of x and f dash of x. So if it is equal to 1, f dash x is equal to what, 0. If it is equal to, say, constant, say k is a constant, then its derivative is equal to what, 0. If it is equal to x, then its derivative is equal to 1. If it is equal to x square, then it is equal to twice x. Similarly, if it is equal to x raised to n, that is x raised to n, then its derivative is equal to n x raised to n minus 1. Similarly, if it is equal to 1 by x, then it is equal to minus 1 by x square. Okay. Then next, if it is equal to 1 by x raised to n, then it is equal to n minus n x raised to n plus 1. If it is equal to e raised to x, then its derivative is e raised to x. If it is equal to log x, then its derivative is equal to 1 by x. Similarly, if it is equal to 2 raised to x, then it is equal to 2 raised to x log 2. Or if it is equal to a raised to x, where a is a real constant, then it is equal to a raised to x log a. If it is equal to, say, sine x, then its derivative is equal to cos x. If it is equal to cos x, say cos x, then its derivative is equal to minus sine x. If it is equal to tan x, then its derivative is equal to sec square x. If it is equal to, say, sec x, sec of x, then it is equal to sec x into tan x. if it is equal to say cosec x, that is equal to minus cosec x into cot x. If it is equal to cot x, then it is equal to minus cosec square x. Similarly, if it is equal to say there is one you can write say trigonometric function, say sine inverse x, that is equal to 1 divided by square root of 1 minus x square. Okay, correct? Sine inverse x. So I want to check here what is sine inverse x. Yes, 1 divided by 1 minus square root of 1 minus x square. For cos inverse x, it is equal to minus 1 divided by square root of 1 minus x square. Next, say tan inverse x, it is equal to 1 divided by 1 plus x square. Say similarly for cot inverse x, it is equal to minus 1 divided by 1 plus x square. For tan inverse x, cot inverse x. Then next for sec inverse x, it is equal to 1 divided by mod of x in square root bracket x square minus 1. For cosec inverse x, it is equal to minus 1 divided by mod of x square root of x square minus 1. Now there is one more function left. If it is a square root of x, say if f of x is equal to, say f of x is equal to square root of x, then its derivative is equal to derivative of f of x, independent variable is x, it is equal to 1 divided by 2 root x. What is, if it is equal to square root of x, then if f of x is equal to square root of x, then its derivative is equal to what? 1 upon 2 root x. Okay, and so on. So this is the list of the function and its derivative. So memorize this formulae. By using this formula, you can solve any example of derivative. And if you know some algebra of derivative, that is first, if it is equal to, say, if derivative of f of x plus g of x is equal to derivative of f of x plus derivative of g of x. So for example, if you want to determine d by dx of x square plus sine of x, then its derivative is equal to, take a separate derivative of x square, that is twice x, and take the separate derivative of sine x, which is equal to what? Cos x. In Maxima also you can write the addition of two, you can take a derivative of two function. Say if f of x is equal to say x square plus sine of x, and if you write here derivative of f of x, independent variable is x, then you will get it is equal to what? Derivative of x square is equal to twice x, and derivative of sine x is equal to what? Cos x. Similarly, this is the one formula. Second, now derivative of d by, similarly you can find a negative also. F of g of x, composite function, is given, then it is equal to f dash g of x into g dash of x. That is, suppose you want to determine d by dx of sine x square, then the derivative of sine x is equal to cos x square, and again derivative of x square is equal to what? Twice x. So this is called the derivative of composite function. So in Maxima you can also find a derivative of composite function. Say f of x is equal to say sine of x square, say x square. Okay, and the derivative of f of x, what is f of x here? Sine of x square, and in terms of variable x, so it is equal to twice x into cos x square. So derivative is what? Twice x into cos x square. So you can check here, twice x into cos x square. If we take one more example, say f of x is equal to, or you can direct take a derivative, say derivative of exp, exponential function of twice x, independent variable is x, you can check it is equal to e raised to twice x, and derivative of twice x is equal to 2. So sorry 2 into x, 2 into x. So now you can check, so you cannot enter twice x, it is what 2 into x, so it is what 2 times e raised to twice x. So this is what about the composite function. Next you can take a derivative of multiplication also. So d by dx of f into g of x is equal to derivative of f of x into g of x plus f of x into derivative of g of x. So for example, if you want to determine d by dx of x into sine of x, so derivative of see x square into sine of x, so derivative of x square is, say derivative of x square is twice x into sine of x as it is, plus sine of x into derivative of say it is equal to x square into derivative of sine x is equal to what, cos of x. So x square into derivative of sine x is cos x, and sine x into derivative of x square is what, twice x. So first we take derivative x square, which is twice x, and sine x as it is, then plus x square as it is, derivative of sine x is equal to what, cos x. So in Maxima you can also find a derivative of if the product of two function is given, say f of x is equal to x square into sine of x, and if you want to find a derivative, just enter command derivative diff of f of x in the variable of x. So it is equal to, you can check here, twice x, first derivative of x square is twice x, sine x as it is, then x square as it is, and derivative of sine x is equal to what, cos x. So this is, by using this definition you can find derivative of product function. Next, if it is say if it is given d by dx of, you want to find f of g, f divided by g of x, then it's g into f of x minus f of x into g of derivative of g, sorry, I am writing one more time, say just forget this, I am writing here d by dx of f of x divided by g of x is equal to, say g of x into derivative of f of x minus f of x into derivative of g of x divided by g of x bracket square. So for example, if we want to determine, say d by dx of sine x divided by x, so it is equal to x into derivative of sine x minus sine x into derivative of x, okay, and this divided by x square. So if you simplify this, if you take a derivative, so say here x into cos x minus say sine x into derivative of x is 1 divided by x square. So derivative of x is equal to 1 and derivative of sine x is equal to what, cos x. So in Maxima, say here if we enter, say f of x is equal to say sine x divided by x and derivative of say f of x, independent variable is x, then it is equal to, you can check here, cos x divided by x minus sin x divided by x square, but it is again the calculated value here we calculated, okay, it is x cos x minus sin x divided by x square, but here it is what, cos x divided by x minus sin x divided by x square. As we know that to simplify this function, just enter rat simp, and since it is a previous command, just enter %, and you will get it is equal to, say sin x, again it is what, minus sign outside, so it is minus become plus, so it is x cos x minus sin x divided by x square, since it is minus sign outside. If you more simplify, maybe to simplify further, rat simp, say %, We are going to check whether it is simplifying or not. No, it is not simplifying further. So this is the final answer. It is what? So if you simply multiply this minus sign inside, then it is what? X cos x minus sin x divided by x square. X cos x minus sin x divided by x square. Similarly, if it is equal to, say, f of x is equal to, say here, f of x is equal to say x divided by sine of x equal to, and say derivative of f of x in terms of x, then it is equal to 1 minus x cos x divided by sine square x. So now if we find here, if we calculated the derivative of d by dx of, say, x divided by sine of x, then it is equal to sine x into derivative of x is 1 minus x into derivative of sine x is equal to cos of x, this whole divided by sine square x. So this is equal to what? Sine x minus x cos x divided by sine square x. But in Maxima we obtain here 1 by sine x minus x cos x divided by sine square x. So again, if we simplify this, rat sims, then we get it is equal to sine x minus x cos x divided by sine square x. You can check here, sine x minus x cos x divided by what? Sine square x. And in Maxima also we get sine x minus x cos x divided by sine square x. So by using Maxima you can find a derivative of any function. You can find. You can find addition as well as derivative of multiplication, divide. If the divide of two function is given, you can find. So this is the list of formula for the given function and its derivative. If you memorize this and if you know some Maxima command of derivative, you can find a derivative of any given function. Any complicated function you can also find a derivative. So for example, if you have a say you want to determine, say, f of x is equal to, we are going to take very complicated function, say f of x is equal to say x square root of say square root of twice x 2 into x plus 8 tan of x into, say, x square, this whole divided by, or this is a function, and so square root of twice x 8 tan x into x square, and we want to determine derivative here, derivative of f of x independent variable is what? X. You can check. So it is equal to what? This is the derivative, twice x 8 tan x plus x square divided by x square plus 1 divided by square root 2 into root x. If you want to simplify this, just enter command rat same, and since it is a previous command, enter percentage. Okay, it's simplifying, but I think so you'll get this is a simplified answer for the derivative of this complicated function. So for any complicated function you can find a derivative. Okay, thank you.